Hi there, in this video we're going to talk about solving equations by multiplying or dividing decimals. Now as a recap, we will go over two properties of equality that will help us to do this. So the first one is the division property of equality. The second one is the multiplication property of equality. I have examples here with whole numbers that we've done before, that we're used to. These are easier than with decimals. And the first example is 5x is equal to 20. And for this one, the relationship here is 5 times x. Anytime you see two numbers attached, a number attached to a letter like this, it's multiplication. 5 times x is equal to 20. So because 5 is multiplying x, my goal in solving equations is to isolate the variable, get the variable by itself. And so I do the inverse operation or the opposite operation. So here, because it's 5 times x, I want to get rid of the 5, so I divide the 5. All right, so I'm going to divide using the division property of equality. I'm going to divide 5 on both sides. All right, so 5 divided by 5, that's just 1. So I'm left with 1x is equal to 20 divided by 5 is 4. 1x is the same thing as x, so x is equal to 4. And if you think about it, 5 times 4 is 20, so we know we're right. Now, this division property of equality, all it states is that you can divide an equation by the same number without changing the equation. So that's what we did here. Our equation is still the same, even though we divided both sides by 5, because that's what the division property of equality tells us. Okay, let's go to the multiplication property of equality. So here we have x divided by 3, right? This bar here is division, is equal to 9. All right, so because we want to get x by itself, isolate x, we want to get rid of any numbers or anything else that's not x. So here we have 3. 3 is being divided. The inverse operation of division is multiplication, or the opposite operation is multiplication. So because 3 is being divided, we're going to multiply 3 on both sides. Now this is using the multiplication property of equality, which tells us that I can multiply the same number on both sides of an equation without changing the equation. My equation is still the same. Okay, so here we have our multiplying here. So we're going to get, remember, 3 is the same as 3 over 1. So 3 over 1 times x over 3 is equal to 9 times 3. So on the left side, we have 3x over 1 times 3 is 3 is equal to 27. All right, now 3 over 3 over here, this is just 1. So again, we have 1x equals 27. And remember that we said 1x is the same as x. So this means that x is equal to 27. Okay, so we're going to apply this and we're going to use it. First, we're going to focus on the division property of equality. So let's go to our first example that has decimals. Okay, so we have negative 0.5x is equal to 20.5. Again here, negative 0.5 is multiplying x. So we need to apply the division property of equality by dividing negative 0.5 on both sides. So I have negative 0.5x is equal to 20.5. And to isolate x, I need to divide both sides by negative 0.5. Okay, so here I'm going to have negative 0.5 divided by negative 0.5. What you see here, this is going to be 1. So I'm going to have 1x is equal to whatever I get here. Now, because it's a positive number divided by a negative number, my answer is going to be negative. So let me just figure out what my answer is going to be by doing my division over here. And let me use a different color for this. All right, so I have 20.5 divided by 0.5. Now remember, when we're dividing decimals, for the divisor here, you need that to be a whole number. So we can move that decimal place once, and we have to kind of do the same thing here. Technically, what you're doing is you're multiplying both of them by 10 in doing that, and you're not changing it because you're doing it to both of them. So it's still the same problem. So this is going to be 5 into 205. Same thing as that. Okay, if I move that decimal point to the back for each. Okay, so here 5 into 25 goes into 24 times. 5 times 20 is 20. You subtract that. You're left, you get 0. You bring down your 5. 5 into 5 is once. So 5 times 5 is 5. You subtract that, you get 0. So you're done. Our answer was 41. So we have 1x is equal to negative 41. And so x is negative 41. Now we can always check this, right, to see if we're right by multiplying 41 and 0.5. Now we know that our answer is going to be negative, well, we know our answer should be positive because negative 40, we have negative 41 and negative 0.5, so our answer should be positive. So if I multiply this 1 and 5, gives me 5, 4 and 5, that's 20. And then for the 0, you just get 0, 0. So you add that, you get 205, but there's one decimal place here, so there should be one decimal place in your answer. So 20.5. And it should be positive because 0.5 was negative, and then it's negative 41 here. So our answer is correct. We did get 20.5. So we know we're right. Okay, why don't we go to the next question? Okay, so let's do a word problem here. I love word problems. Here we have Kofi has $39.78. Now, Kofi is a Ghanaian name of a boy born on Friday. So that's a fun fact. Any boy born on Friday could have the name Kofi. Okay, so Kofi has $39.78. He wants to buy Halloween candy for a party. If each packet of candy costs $1.50, how many packets of candy can Kofi buy? All right, so let's try to figure this out. If he's buying candy, to figure out how much he's gonna pay in total, right? You would have to multiply the price of each packet by the number of packets he gets. Okay, so for instance, if it was one packet, it would be $1.50 times 1. If it was 2 packets, it would be $1.50 times 2, right? To get $3. If it was 3 packets, it would be $1.50 times 3. So you can always figure out how much money he spends by multiplying the price per packet, right? The price per packet for each packet by the number of packets. Okay, so we're going to use this to set up our equation, right? Our price per packet, let's say it's called PPP, price per packet, times the number of packets, NOP, is equal to total cost in this case. All right. Okay, so why don't we fit in our numbers, and we're going to fit in a letter where we don't have a number. So Kofi has $39.78. So that's going to be his total cost because that's what he has to spend. It could be he might have some left over if he's not able to buy a full packet. He wants to buy Halloween candy for a party. If each packet costs, so our price per packet is $1.50. And the number of packets we don't know. So we're going to replace this with a variable. Let's say it's number of packets for P. So we have $1.50 times P, and I'll use a decimal here. Sorry, a dot for the times. $1.50 times P is 39.78. So I can rewrite this as 150P is equal to 39.78. And then let's see how we can solve this. So again, we have $1.50 P, 1.5P is equal to 39.78. And we need to find P, we need to isolate P. So of course we have to divide both sides by 1.5 using the division property of equality. Okay, so now we have P because this is, you're gonna get 1 over here. So this is 1P, which is the same thing as P. So P is 39.78 divided by 1.50 or 1.5. I don't really need that, but let's see. Okay, so let's try the division here. So we have 1.5 into 39.78. Now, because we have this decimal, we need to move it. So what we could do is we could just we can move it twice, so we can move this twice and have no decimals left. So 1, 2, and then we have to move that the same number of times so we don't change our problem. So this is the same as 3978 and then 150 into that. All right, so let's see what this looks like. So 150 into 300, we can do twice. 150 goes into 300 twice, so we can subtract 300, and then you have 97. You subtract that, you bring down your 8. Now 150 can go into 900. I think that's 6 times. So 150 times 6 is 900. We can subtract that, and then we have 78. Now we don't have enough for 150 to go into 78, so we start introducing a decimal. All right, so now once we do that, we have 0 in the tenths place here. We can bring that down, so we have 780 tenths now. Okay, so 115 to 780, 150 can go into 700 5 times, I believe. So 5, no, 150 goes into 750, not 700, 750 5 times. So 150 times 5 is 750, so I'm going to subtract that, and that gives me 30. Now I can bring down a 0 here as well. Keep going with that. So 300, 115 to 300, 2 times, that's 300. You subtract 300 and you're left with 0. We're done. So we had 26.52. So our answer here is going to be P is equal to 26.52. Now, the question is, how many packets can he buy? Obviously, he can't buy 0.52 packets. So we're going to say Kofi can buy 26 packets. He's just going to have a little bit of money left over. All right, so that's it. Until next time.